Welcome back to another one of my applications of differentiation videos in my series, and today we'll be focusing on finding critical points. This is the fourth episode, obviously, judging by the four, and yeah, I'll show you how to find critical points. So basically have this thing. I will do an example after. If you've already seen this, just skip through to the example. But critical points, to find them, you find a critical number, then you use the critical number to see if it is a point. Okay, so to find the critical number, you set the derivative to 0, or you set it to being undefined or to not exist, does not exist. And then once you have that number, then you sub that back into the original function and find out whether it is defined, which means it exists within the domain. And if it is defined, then it's good. That means it's a critical point. If it's not defined, then it's not a critical point. It may be a critical number, but it's not a critical point. Okay, and this, if you not quite sure about defined and undefined, well, does exist means you set the top to 0. Usually, you would do this in a fraction. You would do it does exist and does not exist. So if it does exist, you would set the top to 0 and work out the top, solve the top. And if it doesn't exist, you would set the bottom to 0 and you would solve the bottom. Because you can always take nothing of something, but you can't take something of nothing. That's the idea. That's how I remember it. Anyway, so let's start with our example. Example 1. So we have fx equals sine x. Okay, nice and easy. The derivative of sine x is cos x. Okay, and because we don't have a fraction, we're not going to set the bottom to being undefined or setting it to 0, because it's just a one-liner. There's no fraction. So because we've only got one thing we're focusing with, like the cos, we're going to set the derivative to 0. Because we're only working on the top, which means 0 equals cos x. And how do we get the cos over this side and away from and isolate this x? Well, we inverse cos on the other side of 0 equals x. Okay. Now, what we do now is we find it x. Well, it tells us that x equals pi on 2. It'll spit out a decimal, but that decimal will equal pi on 2. Should. Okay? And also, what you may not know, or you may know, is that on a cos graph, you have 1, 0, and negative 1. Okay? And the cos graph has couple of points, probably one over here. I'll try and make that over there. Anyway, so it basically starts like that, goes down to negative 1, scoops back up, back to 1 again. Okay, so when cos x at 0 is at this point, and this point. And this point here is pi on 2, and this point here is 3 pi on 2. This one here is pi, and this one on the very end is 2 pi. 2 pi is a full period, or like a full cycle. Okay? So what we're going to do is we're going to say, well, you could just say x equals 2 pi minus pi over 2, and that will give you the 3 pi on 2. Now, if you think about it, because this just goes on and on and on and on, you could just keep on adding on and keep saying, well, there's just heaps and heaps of critical numbers, because it'll hit there, it'll hit there, it'll hit there, and then it'll hit there, and then it'll hit over here, and it'll keep going on and keep hitting those numbers. And you can't, and basically it does. And so what you do is you say x equals pi on 2 plus 2 pi n. And that 2 pi n, n means like, is basically the number of cycles. Think of it as a number of cycles. So you have 1, and then 1 from that point, and it will give you the pi on 2 in the next cycle. It'll give you a number which will equal the same as the pi on 2 in the next cycle. So this here is the distance of 2 pi. And when you add pi on 2, it gives you that, which means by adding this and the n, which means like basically means the number of cycles, it will give you that distance, which will give you the pi on 2 essentially in the next cycle. Hopefully that makes sense. And same with this one. X equals 3 pi on 2 plus 2 pi n. Because you're basically saying that's the cycle. N just means how many cycles. And this, well, that just means you start at this point. So that if you have one more cycle, it'll give you not this 3 pi over 2, it'll give you the next 3 pi over 2, but it'll add it. And basically you can play around with it if you want, but that's the general idea. Okay? And so now we have our critical numbers. We're only going to work with these two because it's just easier working with one cycle, and we've written a formula which can give us any other following x values, critical numbers. So now we're going to input this back into in the function, which will tell us if it's defined or not. And so f, we're just going to do pi over 2. Like, we're not going to worry about the extra cycles. We're just going to do this because this is within the first cycle. It hasn't had any additional cycles in this case. So that's going to be sine pi on 2, which equals 1, which is tick, because that means it's defined. It's within the domain. And now we're going to do we're going to input 3 pi on 2 back into the original function. So that's sine 3 pi on 2. And that's going to equal -1. And that's good, because it spit out a number. If your calculator has a fit, it basically means it's if it says mathematical error or something like that, it means that it's not defined. If it spits out a number, you're all good, unless you typed it in wrong. So that means that these points here, both of them, are critical points. They're critical numbers, but they're also critical points. And when you think about it, a sine graph is just like a cos graph. Well, because they're very similar in certain ways. You have your pi on 2, you have your pi, you have your 3 pi on 2, and then you have your 2 pi. And the sine graph basically goes like that. Which makes sense, because pi on 2, which is this one here, it equals 1, which is this point, which is the local maxima. And over here at -1, 3 pi on 2, we have ourselves a local minima. So they are critical points. And I'll go into detail about local maximas and minimas and maximums, global maximums and minimums in another video, but I'm just showing you critical points at this point. But anyway, thanks for watching this video. I hope you learnt something, and have a good day.